I want to go to the calculus grading so I can be there with thousands of other calculus teachers, and then it'll be like my people. It'll be, yeah, like the coolest people you can imagine all in one place. So, I'll probably have great stories to tell about it. Okay, so, alright, so, a manufacturer wants to design an open box having a square base. Guys, quiet and paying attention. A square base and a surface area of 108 square inches. What dimensions will produce a box with maximum volume? Alright, so, for whatever, this is sort of like, yes, I could see how this would happen in a manufacturing setting where you're making this box and you certainly want to maximize your volume and you know you have a certain surface area. Now, it's a little oversimplified for our particular, uses here. So, it would be a little more complicated if we were actually looking at manufacturing the boxes, right? Because we would probably have a lot more to do. But stuff like this goes into, any type of packaging that you're going to put items in if it's like something mass produced, right? So, something to consider. So we have a square base, and it is an open box, so it does not have a top. It does not have a lid. So, if we draw ourselves a picture of what this would look like. Only the base is square. So we would know maybe like this side right here is X, this side right here is X, and I'm going to call this right here my height. Alright, so we have two things about this box that we can talk about. We can talk about the surface area, and we can talk about its volume. So, on the AP exam, there is no formula sheet. There's no formula sheet. If they're going to give you a formula, they will give it to you in the problem. I don't think they would give you any formulas for this problem because they expect you to be able to find volume of a box or surface area of a box on your own. So I don't think you would be given a formula here. Now, if it's a sphere, they usually give you the formula. If it's a cylinder, probably. But usually for just anything rectangular, you're not going to get the formula. So if I want to know the volume here, what would I do? X squared times h. All right? X times X times h. All right. It would be length times width times height, but I've called both my length and my width x here. So x h gives x squared times h. All right. Surface area. Okay, now, that is not like a standard formula that you're going to know, especially since this is an open box. So, Daniel, tell us what you did to figure out that.
So, it's one side, which is x times x, and right. Then it's x times h for one side, and there's four sides.
All right, so this bottom would be x times x, right? Because we're just talking about the area of that bottom part. That's our x squared. Then you've got 1, 2, 3, 4 lateral sides, those sides that are up and down. And each one of those are going to be x times h. And there's 4 of them, so we have 4 here. If this box had a top, had a lid, what would we have to do? We'd have a 2 in front of our x squared, but it does not, so we do not put that there. All right, and this is 180, or not 180, 108. Okay, so what are we going to maximize? What does it ask us to find a maximum of? Which volume, right? So this is our formula to maximize? Eventually we're going to do that. So, now if I want to find the maximum of something, quiet please. If I want to find the maximum of something, I take its derivative. I set its derivative equal to 0. I find critical points. I can test, right?
Yeah.
But can I do that whenever my formula has an x squared and an h? I cannot. So, optimization problems, you're going to have two equations that you end up coming up with. And then you're going to have to substitute in, which I think I heard Chandler say back there. So, you could solve this equation for x or for h, but which one is easier to solve for? H. You're going to have to do like some crazy complete in the square stuff if you want to solve for for x. So, if we solve for h, we just need to subtract that x squared. So we get 108 minus x squared equals 4xh. And then what do we do? By 4x. So my h is going to equal 108 minus x squared over 4x. And we will take this and we will plug it in for our h. So that will look like this. We'll have v equals x squared times 108 minus x squared over 4x. And I will go ahead and give you a prior warning. Some of these problems are a little bit long, and if you really like for your work to be neat, you might just want to do it on an extra sheet of paper for some of these. We got a little ways to go still. You can't get a value for x. You can't plug in x for h. Because if you solve this equation for, because it's the same equation, so like if you solve this equation for x, you'd have v over, square root of v over h. You'd have a v in your problem, so you can't do that. So, let's simplify this a little bit here. So, if I have this 4x on the bottom, and then this x squared is in the numerator, I could cancel one of those x's there. And so that leaves me with v equals x times 108 minus x squared over 4. And then if all I did here is cancel this x squared, I cancel one of it with that x that's in the denominator here. And then I really want this to be all together, so if I multiply that together, I get x times 108 minus x squared over 4. And I could distribute that x, so I'd get 108 x minus x to the third over 4. And since the denominator is just 4, it's not a variable, right? What I'm going to have to do is I'm going to have to take the derivative of this. And if I have to take the derivative of this, I would rather not have to do like a quotient rule here. So I could do the love connection here, divide both of those by 4. And 108 divided by 4 is going to be 27. And then right here we'll just have 1/4 x to the third.
And then you find
Quotient rule is going to be a lot harder to do the derivative for. Yeah, quotient rule would be much more difficult. Especially like everything that comes after that, plugging back in, all the other stuff. Quotient rule would be much more difficult. Because if you don't simplify here, you're going to have to simplify after you take the derivative using the quotient rule. So I would highly suggest doing this instead of quotient rule here. So this is my volume formula. I want to know when volume is the maximum. So if I want to know the maximum, and this is not calculator active, and a lot of times these show up not active, you need to take the derivative, right? So I'm going to call it dv dx, or you could call it v prime, fine. It's going to be 27 minus 3/4 x squared. I'm going to set that equal to 0, which is going to be 27. No, v prime is perfectly fine. And then I'm going to divide by 3/4, which really means I'm multiplying by 4/3 over here. Remember that you can cancel the 27 and the 3, so that's a 9 and a 1, so you get 36 equals x squared. And then square root both sides. We get x equals plus or minus 6. X is our length of our box. Does it make sense to have a negative here? No. So we're not going to be concerned with negatives because it doesn't make any sense to have a negative length in this case. So we really only need to check 6. I should call. We're really hoping that that 6 is probably our positive than negative. Even though, yeah. So, if we plug in a number between 0 and 6, such as 1, we get 27 minus 1/4, that is going to be positive. But if we plug in a number bigger than 6, such as like 10 or something, not 2, because 2 is not bigger than 6. We get 270 minus 1/4 of hold on. Have I messed up? I'm sorry, derivative. Sorry, I'm not plugging into. I plug into the derivative, so I get 27 minus 3/4 here, still positive. If I plug in something like 10, I'd get 27 minus 3/4 of 100, which would be negative 75. So that'd be a negative right there. Alright, so since we go from positive to negative, 6 is going to be our maximum, or where our maximum will occur. And I need to scroll back up and see what it was asking. What dimensions will produce a box with maximum volume? So it didn't ask for the volume, it asked for the dimensions. So it would be 6 by 6 by, how do I find the height?
You can plug in 6 for x squared.
Plug in 6. Probably the easiest place to plug it in is right here where it's already solved for h. So h equals 108 minus so we get 108 minus 36 over 24, which is going to be 72 sounds right. Yeah, 72 over 24, which is 3. So H is 3. So this is feet, or this is inches. So 6 inches by 6 inches by 3 inches would give us the maximum volume. Yes. Yes. And the tricky part about this is you have to come up with your equations on your own. So everything we've done so far, they gave you an equation. They said find maximum or minimum. So that, you didn't have to think about what equation you were using at all. But for what we're doing now, you have to come up with the equation on your own, which can prove to be much more difficult at times.
Solve it for one of the variables so that we can take the derivative of the equation we want to look at. Find a critical point and then find the speed. What if it wasn't an accident?
It usually is, but and there's a possibility sometimes there might be more than one, so you got to figure out which one it is, but it usually is the maximum or minimum. Yeah, sometimes there can be more than, sometimes you might have more than one critical point. One might be a minimum, one might be a maximum. So, right, it's pre-calc until we take the derivative. So we're just doing substitution, all of this. If they asked us for a volume formula in terms of just the x, we would do that in pre-calc. What class was that? Not my pre-calc, right? Okay, I was gonna say. All right. Okay. All right. Now this is definitely just like a math teacher sort of problem here. This one doesn't have the most application, but it is an optimization problem that you sometimes see on the AP exam. So, which points on the graph of y equals 4 minus x squared are closest to the point 202? So, let's sketch us a graph of this. This would be calculator inactive. I've seen it as a multiple choice. Not necessarily, because they're asking you the distance, which, like what we've got here, we've got an upside down parabola with a vertex at 4. So it looks like this. So, and they ask us about the point 02, which is right here. So, you could plug it, if they just gave you points, you could plug some of them in. But it's not going to be just as simple as like, oh, I can graph it and see which one is, because the question is, I'm gonna freeze this so I can erase. But like, if I want to know what's closest, these points right here look pretty close. But like, is that one right there a little bit closer? I think like if it's kind of perpendicular, it's the closest. You know what I mean? Like, we could think like straight out, that's definitely longer, right? But then I got to figure out what that point is. I can't just guess, oh, it's like 1.1, 2.7, right? Now, that my guess is something like this. If it did show up on multiple choice, they're very good at finding ways where you can't just estimate your way into it, so they might ask it in like sort of a strange way. So we need to know what is closest. So let me actually, I'm going to erase this right here. We can see one of the reasons I really wanted to graph this is because I wanted you to also see if you have a positive x, there's going to be a negative x that also goes with it. So we should have 2 points, right? Whatever point we end up with over here, we're going to have that same over on the other side, but negative. So we know for sure this is the point 0, 2, right? Let's call this the point, I'm just going to call it right now, xy. What is it we're trying to, are we maximizing, minimizing? What are we trying to do here? Minimize distance, right? Closest point. Distance needs to be the smallest. How do I find the distance between 2 points?
It's the line.
Distance formula, which is, it's basically Pythagorean Theorem. Or your x's can be first. It doesn't matter if you write your x's first. It does not. Because that plus sign right there in between. Okay. Is that 3 plus 2? No. 9 plus 4 is the square root of 13, which is not 5. So if you have that plus sign right there, you can't square root the two things separately. Okay, well that is the fact. If you see a square, you do need to square it. Okay, I'm not sure if we're... No, squares do not cancel out. Yes, like square root of 3 squared, they cancel. You would get square root of 9, which would just be 3. But if it's square root of 3 squared plus 2 squared, alright, let's do it the other way. Square root of 9 plus 4, which is the square root of 13. Which one's right? This one is right. No, you can't do that. Just take my word for it. You cannot do it.
If it's all squared, like everything under the square root is square, you can't do it.
Correct. So if it looked like this, then you could cancel it and it would just be fine. But alright. Okay, so if I'm finding the distance between 0, 2, and xy, I could do y minus plus 2. You're messing me up. Y minus 2 squared. That's not a plus or minus. It's just a plus. Oh, sorry. No, it's not a plus or minus. I just put a mark there on accident. X minus 0 squared. Okay, so this is the formula that I need to minimize. If only I could smack the students. Maybe I should smack his desk with the ruler when he's getting out of hand. I don't want to harm Thomas. But I do want to knock the idea that you can square root those squares out of your head. Or keep it close by. Yeah. Okay, so we need to minimize this. What's the problem, though?
Letters and numbers don't add together.
Our problem is right here. Quiet. All right. In general, for these problems, you do not want to try to take the derivative while you still have two variables. If you have two variables here, you do not want to take the derivative. Because if you do that, you would have to do implicit differentiation, and then you end up with dy dx's. You can't do anything with it. It's super complicated. It would make it much more complicated to do that. So we need to somehow replace the x or the y, preferably the y. Okay, what can we substitute? Very good. So right here, this is a fact. We know that is a point, right? So we can replace our y with 4 minus x squared. So that will look like this. I'm just going to write this as an x squared now. We probably need to simplify before we try to take a derivative because it would be really ugly right now. So we would get 2 minus x squared plus x squared, which is going to be, if we square double square here, we'll get 4 minus 4x squared plus x to the 4th plus x squared. And then we can put those x squareds together. So yeah, x to the 4th plus 3x squared plus 4. Which I put right here for my y, right? But you also still have that minus 2. Yes. X to the 4th minus 3x squared plus 4. We do. But I'm going to tell you a shortcut. Okay? Because taking the derivative of that is not going to be easy. Because you've got to do a chain rule. You would have to have like x to the 4th minus 3x squared plus 4 to the, or 1/2 times that stuff to the negative 1/2 times the derivative of the inside. It's going to be a big mess. You could do it, but it's going to take a really long time. But let's think about taking the square root of something, right? The bigger the number is, the bigger its square root is going to be. So, like, for example, if I have square root of 721 and square root of 894, which one's bigger? The square root of 894. I know that. I don't have to take the square root of each one to know that because I know the square root of the bigger number is going to be the bigger number, right? So we really only care about what is underneath the square root. If it is a maximum, then the whole thing will be a maximum. So the way that we can deal with this so we can take an easy derivative instead of a difficult derivative, we are going to say D is or has a maximum when use a y right here instead of the d, because this is not distance. This was what's under the square root. Whenever this has a maximum. So finding the maximum of d is very difficult, but finding the maximum of y equals x to the fourth minus 3x squared plus 4 is much easier because it's got a really easy derivative, right? So we can, as long as we write this, now we can just take the derivative of this, so we could call it y prime or dy dx, whatever you want to call it. It's going to be 4x to the third minus 6x. We will set that equal to 0. And factor out the x. You could take a 2x if you want to, yeah. We'll get the same answer either way. So we get x equals 0 and 4x squared minus 6 equals 0. So 4x squared equals 6. Divide by 4. X squared equals 3/2. We could square root both sides. And put that plus or minus there. Does it make sense to have a negative on this one? This is our x value. Does it make sense to have a negative here? And we said we would actually have a positive value and we'll have a negative value for x because we're going to have 2 points that are the same distance away. Yes? If it was not like symmetrical, then you would probably only, you might get two numbers to test, but you'd probably only have one maximum. Like only 1 point would actually be maximum. You still would, yeah, you're right. You still would not just throw out the negative though, because it might be the negative point that's actually closer. Right, right. And we're going to consider this. So if we do a sign line here, we're going to include negative square root of 3 over 2, 0, and square root of 3 over 2. And call this y prime, not d prime here. And so if we plug into this, if I plug in something less than negative square root of 3 over 2, like negative 10 something, we would get 4,000 minus 60. You'll get a positive here. Something between negative square root of 3 over 2 and 0 would be like 1. If we plug in 1, we would get a negative. Actually, hold on. 4 times, sorry, I should be saying negative 1. Negative 1 cubed minus 6 times negative 1 is going to give you negative 4 plus 6. Hold on, have I messed up? Square root of 2 over 2 would just be square root of 1, which would be 1. So square root of 3 over 2 is a little bit bigger than that. So negative 1 would fall here. Hold on. So was I wrong about 4 times? Oh, I should have, sorry, I'm not thinking negatives. I was using positives when I was plugging in. Negative 10 to the third minus 6 times negative 10. This would be negative 4,000 plus 60, which would actually give us a negative there. I'm just picking a number smaller than negative square root of 3 over 2, and I chose 10 just because it's easy to cube. Whereas, like, if I chose negative 5, I'd have negative 625, which would not be as easy to deal with. And then, so if I plug in positive 1, 4 times 1 cubed minus 6 times 1 would give me 4 minus 6, so I'd get a negative here. And if I were to plug in a positive 10, if those were positives, I'd have a positive 4,000 minus 60. I'd get a positive here. Yes, we are, so I should change what I wrote right here, shouldn't I? Yeah. It may be one of those things that, since what you wrote is true and shows you understand it, they'd probably still give it to you even though you should have said minimum there. Alright, so minimums are going to occur right here and right here. And it does not say just the x-coordinates, so I think we need to find the y-coordinates. Y-coordinates are not as bad to find as you think. What should we plug back into to find the y-coordinates? We're going to plug back into the original, 4 minus x squared, because that will give us a point on this graph. So we would take the 4 minus square root of 3 over 2 squared would give us 4 minus 3 halves, which is going to be 5 halves. Is that right? Yeah. So we would have one of these points, the one over here, would be square root of 3 over 2, 5 halves. Will it change anything if I turn that square root of 3 over 2 to a negative? It will not. So over here, we would have negative square root of 3 over 2, 5 halves. And those will be our answers, and that is exactly what Daniel would have guessed from the beginning. Exact answer. I think I heard him say square root of 3 over 2, actually. Okay. And so those are the exact points that it's the closest. You do not get a protractor or a ruler. So. Okay. Usually, one year I was given the Math 1 EOC to Miss Ball's students whenever she was still up here, and I watched the kids take their extra graph paper and fold it. And then I saw them holding their paper up to the screen, using it just to measure, like for distance problems, instead of doing distance formula like we just did. She had taught them just to measure the screen. Yeah. So, as long as your graph paper has the same size square as your screen, it does actually work pretty good.
Just like Pythagorean Theorem and stuff, like multiple times, and he's like, I think it's 15, and he's like, and it was 15.
Yeah. Yeah. Coach, we're actually going to, we got to find area of irregular shapes in here whenever we do area under the curve. And often Coach Wood comes into class and we're doing those problems, and we'll ask him if he wants to do a problem, and that's what he'll start doing. He'll say 10, those two, 11, 12. He'll do that.
If it's multiple choice, you get more than
it probably won't work that well on the AP exam because they know how to make that. The people who make the AP exam are like a group of evil geniuses that can really make a test that is. It's a good test. Okay. All right. So 3. We've got a rectangular page. It is supposed to contain 24 square inches of print. The margins at the top and bottom of the page are 1.5, and the margins on the left and right are 1 inch. What should the dimensions of the page be so that the least amount of paper is used? Okay, so let's always draw a picture. All right, so we've got a page. Within this page, this is the case always pretty much. You're not going to write all the way to the very edge of the paper. You're going to have margins set. And so it says our top and bottom margins are 1.5. Just leave that one down there. I need to go there. And our side margins are 1. All right, so I drew mine kind of like a square. I probably shouldn't have done that, but this is not necessarily a square. So I'm going to call this length right here X, and this length right here Y. That's the inside. You could call the outside X and Y. In fact, hold on. Do I want to do that? No, I think.
The outside will be like X plus 3.
Yeah. All right, so we are wanting to minimize the total amount of paper used, right? So the area of the whole thing. So if this part right here is X, then what is the length of the top edge? X plus 2. Good. And then, what is our height here?
Y plus 2.
Not 2. Plus 3, because you got 1.5 for your top and bottom margins. So, you're adding an extra inch on either side here. So, that would add 2 to the whatever the X length is there. And then vertically, you're adding 1.5 to the top and bottom. So together, that'll be 3 inches. Okay. So we're trying to minimize the area of the entire paper, which would be X plus 2. Yeah, sorry. Sorry about that. X plus 2 times Y plus 3. But we cannot take the derivative of this whenever we have X and Y's. We could, but it would be really, really difficult. Okay? So area of the inside, they told us what the area of the inside part is supposed to be. What is it? 24 is going to equal X times Y. It is pretty easy to solve that for X or for Y. You can pick whichever one you want to use. It really does not matter. I just think X is a better variable, so I'm going to divide by X right here. So Y equals 24 over X. So I can take 24 over X and I can put it here for my Y. All right, to take this derivative, you could use a product rule, but I would probably distribute. So what are you going to get when you do X times 24 over X? Just 24. And then you've got plus 3X. What do you get when you do 2 times 24 over X? 48 over x. And then the last will be plus 6. So we could put the 24 and the 6 together and have 30 plus 3x. And I'm going to write this as 48x to the negative 1. We all okay here? All right, so we're going to take the derivative of this. So a prime is just going to be 3 minus 48x to negative 2. We're going to set that equal to 0. The negative 1. Yeah. So that's going to be 3 equals 48. Let's write it over x squared there. And what do I do to solve that? Okay, you can cross multiply. So 3x squared would equal 48. Divide by 3. X squared equals 16. Square root both sides. X equals plus or minus 4. Does the negative make sense here? Okay. So we only really care about the positive. The smallest we could possibly have is 0 because we have nothing. Yeah, no, you can't have negative paper. We've got between 0 and 4, like at 1, if you plugged in 1, you'd have 3 minus 48 over 1 squared. You get a negative here. If you plugged in something bigger than 4, like 10, I like 10 here lately, 48 over 10 squared, that'd be 3 minus 0.48, you get a positive here. Honestly, if it's multiple choice, you can pretty much assume that 4 is your answer, but if it's true response, you're technically supposed to check this. Alright, so 4 is my x here. So 4 inches. How do I find my y?
Plug it into the original equation.
I'd go back up here to this y equals 24 over x. So 24 over 4 is 6.
You have to plug x into
It's easy. You technically could do that, but you got an area that you don't know what the area is for the total thing. Oh, I see what you're saying. Yes, you do need to do that. Yes, sorry. These are x. Let's go back. Yeah, that's our inside. X equals 4 inches and y equals 6 inches, but the question is asking us about the dimensions of the whole paper. So yes, you're right. It needs to be 6 inches by 9 inches. Because what we found here was we found that this side right here was 4, and this was 6. And then, so this side would be 9, and this side would be 6. Hopefully they would not be cruel enough to give you, like, both sets of those answer choices if this was multiple choice.
You could have straight up only you could have just said 6 by 4. Get those are multiple choice. 8 by 3 would have worked, but 6 by 4.
But how do you know? Like, for example, 24 divided by the square root of 5, let's see, is 24 square root of 5 over 5. So how do you know that 6 by 9 is better than square root of 5 and 24 square root of 5 over 5?
What you could do is, with the 1.5, take the multiples of 24. And then
I'm saying that they don't have to be whole numbers. Like on that last problem, we had square root of 3 over 2.
Oh, yeah, I know. But then you would have just got
So,
what you could do technically is take multiples side on the map and just figure out what 1/4 is 1.5.
You can, but it might not be a whole number. It was a whole number. And lots of times it'll end up being a whole number because these are problems in math books that we want to come out nicely. But you can't assume that it'll be one of those whole numbers. And everything we're doing right now is not calculator active, but they could give you something that would be calculator active. Okay, questions? All right, let's see. Let me see. I want to do one more and then give you guys some time to work today. Yes, on the HW. Okay, yeah, let's do this one. Okay. Okay. So, we have two posts. One 12 feet high, the other 28 feet high. They are 30 feet apart. They are to be stayed by two wires attached to a single stake running from the ground level to the top of each post. Where should the stake be placed to use the least wire? I think this is a cool problem. Again, maybe a little oversimplified, but still pretty cool. All right, so you got two poles, and what we're going to do is we're going to have a stake somewhere between these two poles, and we want to use the least wire possible. So let's think of some possibilities. We know this. Yes. Assume that the wire is taut.
I feel like they would need to include that in the problem. Assume the wire is taut.
Because it's not, then you can think that.
I feel like if I put this is impossible to find because I don't know if the wire is taut or not.
I think that would probably be a bad idea.
That also applies to
Okay, so let's think of a few options here, just to run through a couple things. So, on one extreme, let me make this so that, oh, not that. If you have such incredible guessing skills as Daniel Bautista, you could just guess, but the rest of us are going to figure out. So, like, the most extreme examples are, we put one right here, and this wire goes straight down, and then over to the other side. Seems like a really bad place to put this, but technically it could be done. So, if that was the case, then I would have 12 feet here of wire, plus I could do Pythagorean Theorem here, right? 30 squared plus 28 squared equals, so I'm going to use the calculator for the sake of time because this is not like actually part of the problem. I'm just trying to demonstrate for you here. So that is square root of 1684. It's 41.0366. So there we would use a total of 53.0366 feet of wire. Or could do it this way. Like that. That'd be 28 plus all right, so we get 32.311, and that's 60 point something, so that's worse. It's definitely not that. Right, we don't want to do that. But would imagine that the best answer is going to be somewhere here in between. All right, that is what we really want to figure out. It's fine. I just want to have enough room so I'm working up here. All right, so I don't know where this is at. I'm going to call this length right here x. So without even using a different variable, what could I call this length right here? Those are different variables. 30 minus x. Because the distance between the poles is 30. So if this part's x, this is 30, take away whatever that distance was. So 30 minus x. Alright, so if I want to find the length of, I'm going to use red right here. If I want to find the length of this red piece of wire right here, right, I would do x squared plus 12 squared equals c squared. And I would get x squared, let's see, I'm sorry, I would square root both sides. So the length of this side right here is the square root of x squared plus 144. Okay, over here, I'm going to use green for this wire. If I want to do Pythagorean Theorem here, I'd have to do this. 30 minus x squared plus 28 squared would equal the c squared. I would have to square root both sides. So this side right here is the square root of 30 minus x squared. Squares on the outside. Plus, let me write that better. Squares here plus 28 squared. I could go ahead and square. So if I want to write me an equation for the total amount of wire, we'll call it T. It would just be those two added together, right? Square root of x squared plus 144 plus square root of 30 minus x squared plus 28 squared. All right, now, I'm not cruel enough to make you take the derivative of this by hand, because that would be getting to sort of an extensive level of derivative taking here. I do not think you would see that on the AP exam. I do still want you to do this by taking the derivative, because I want you to get that idea, because most of the time these are calculator inactive problems where you have to take this derivative. I realize we could graph this and find its maximum minimum, right? So that is an option, but they will not give you anything on the AP exam where you can just graph it and find the minimum. So I want us to do this by taking the minimum like we've done on the other problems, but I will let us use our calculator, because doing this without the calculator is going to be painful. Most of the time on the AP exam, they would go ahead and give you maybe like a derivative or something. Is Chandler asleep? Oh no. Okay, good. Okay. Oh wait, that's the wrong calculator. I was closing the... Sorry. Alright, so we're going to type in our equation. I want everybody to follow along on their calculator, because some of you guys have some trouble because you do not follow along. it the other day, Daniel. They cost $150. I cannot. I'm sorry. We're just typing in this equation here. So go to y equals and type in this equation. The one I have in blue here. Good place to keep it. Good safe location to store it there. There we go. Sorry. Yeah, only thing I've done is type it in so far. No, right here we're just typing the equation in into y equals. Yeah. Addison's not trying to square root both things back there after we had an extensive conversation about it, is he? Okay, good. You have something typed in wrong. You probably have a parentheses not closed or closed too early. All right. So, I haven't graphed it yet.
You gotta make it like 105.
All right, so really, let's think about what we're looking at. We're talking about x is what we want to know needs to be what x needs to be, right? What's the smallest x could be? 0. What's the biggest x could be? No, 30. So between 0 and 30 is where you would need to look. But I want you to do this derivative way, even though technically I know you could graph this and find the maximum on the calculator. So if we take the derivative on the calculator, we're going to go back to the main screen. We're going to do F3, differentiate, and since this is already in y, we can just say y1 of x. Here's where we got to put the comma x, like this. Aren't you glad I didn't make you take that derivative by hand? Okay? You can copy on these calculators so that you don't have to, you can copy on these calculators so that you don't have to, like, write that down and then put it back in. So to find that derivative, you're doing dy 1 of x, comma, x, close parentheses. All right, we want to copy this. So go up, and you're going to hit the green button and this up arrow right here where it says copy. And then we can either solve setting equal to 0, or we could look at the graph, either one. Let's try solve. Let's see what happens if we do solve. So solve is under F2, algebra. Solve. I'm going to paste equals 0, comma, x. Close your parentheses. Hit your green button before you hit enter. Is it really just 9?
My guess was 23 and 30.
Alright, now, technically we should check to see if this is maximum or minimum. I'm gonna look at the graph. So if I paste that derivative, oh, what happened? I thought you could. Yeah, you can. Yeah. Alright, so if I go to my window, do you guys know how Zoom Fit works? Alright, so Zoom Fit is useful, but it'll really get you in trouble sometimes. If you already have your Zoom Fit does not change your X values, but it will change your Y values so you can see everything in that interval. So if I want to look from 0 to 30, I'm going to go to the window and set my X values from 0 to 30. It might show up when I hit graph, but it may not. I have not used it yet, but the green button and then F2 and then so once you graph, I can see I go from negative to positive, which tells me I got a minimum right here. Since I use solve, I feel pretty sure that's 9. But if you want the graph to look a little bit better, if you do F2 and then Zoom Fit is number 9, I think, isn't it? No, A. Why does it not want to graph? Oh. Okay. It'll give you a little bit better picture if you do that. It wasn't necessarily for this one, but if you have to get your X's like you want them first to use Zoom Fit. The window is the green button and F2. And that is where you change your window. And then to do Zoom, once you have graphed it, so once you hit graph, if you click F2 without the green button. I just changed my X's from 0 to 30. So our answer would be 9 feet. Well, it's not letting me write. 9 feet from the 12-foot pole. I was going to write that down, but it's quit on me. All right. Questions? Daniel, you're always really close.
But I only did the wires. I did the wires and then I solved it.
All right. So, your assignment for tonight, which we're going to do those other 2 examples tomorrow. This is a section we spend 2 days on. Your homework for tonight is 262, 16, 17, 20, and 33. You got about 10 minutes, so everybody start a problem right now. 262. 16, 17, 20, and 33. 262, 16, 17, 20, and 33. So everybody look at your book and try at least one problem before you go. 33. On every problem, make sure you try something, okay? You may get stuck on some of these, but try something.